Hello. Hello. Can you hear me?
Yes, sir.
Okay, okay. Now, okay, fine. Now, do one thing. Keep your mic on mute. Okay, fine. Let's. Okay. Now, today let's continue whatever we have learned in the last class. Now we'll see what is solar radiation geometry all about. Okay. So before coming to this, let's read this definition first. Okay. If you consider theta is the angle between an incident beam radiation, or sometimes known as flux, of represented by this IBN, and the normal to a plane surface, then the equivalent flux falling normal to the surface is given by this formula. Now let's have a look what it is trying to say. Now imagine that okay, any horizontal plane, just imagine, okay, any horizontal plane. Now uh, uh, yeah, on this horizontal plane, and if any kind of a surface, for example, let's say any surface, okay, let this be the surface. Imagine this is a solar panel for the time being, okay, it will be easier for you to understand. Imagine this is a solar panel, okay. Now imagine that this is like making a slope. Sorry, wait a second. Making a slope with certain angle. Okay, let's have a look here with certain angle like this. Okay, matlab with the horizontal plane, this is what this is the imagine this is a horizontal, any kind of horizontal plane, or let's say surface horizontal surface. Okay, now this is imagine that this is what this is the solar PV module. Okay, but it will be easier for you to understand. You just imagine this is a solar module, right? Solar module. Handwriting is very, very bad. Okay, anyway. Now, it is having certain, it is tilted, you can tilted, or yeah, the solar model is tilted with a certain angle with respect to the horizontal surface. Have a look here, right? So let's say this is somewhat like beta. Okay, with certain with some angle, let's let it name as beta. Okay, fine. Now this solar model, okay, this solar module, imagine an imaginary line in such a way that, say, for every surface, I can imagine a perpendicular line. Okay, a normal. I use the word normal. A normal to this solar model. Imagine that the normal to this solar model is this line. Okay, this is normal. Okay, na? Okay. Okay, control. Fine. Let me use with a different color. That will be easy for you to imagine that this is the normal to this. This is an imaginary line only. Okay, the blue line is an imaginary line which is actually normal or perpendicular to the solar model. Okay, now imagine, see, this solar, this this normal. Okay, let me write here normal. Normal to the solar model for the timing. Okay, so let's have a look here. Now this normal to this solar model will coincide with the, imagine that there is another, like a perpendicular line. Okay, to this horizontal surface. This, you can imagine any kind of a perpendicular line. If you have a horizontal surface, you can imagine a normal or a perpendicular line to that particular surface, like this. Okay, so my point is that if this solar model doesn't have any kind of a slope, okay, if the solar model doesn't have, that is when beta is equal to 0. Okay, that is that when the slope is equal to 0, you find that these two lines. Have a look here. Let it be 1 here. This one is 1. Let it be 2 here. When there is no slope, this normal 1 and the normal 2 will coincide when beta is equal to 0. That is when there is no slope at all, you'll find that the normal 1 and 2 will be coincide. Okay, so fine. Now which is tilted at certain angle and its angle is beta. Okay, now imagine that the solar radiation. Okay, solar radiation is some falls like this on a surface. Okay, making an angle theta to the normal. It is making an angle theta to the sun. Imagine that the beam radiation. So the solar beam radiation. I told you when we talk about solar beam radiation, it is a kind of a radiation. Somebody, I think the mic is on. You please turn off your mic. Dear students, one of you is we have turn on the mic. Okay, please turn it off. So beam radiation, the solar beam radiation on this point, on the imagine that is falling on the, and it's making an angle theta with respect to the normal of the solar model. Okay, take it. Now imagine that the IBN that we talk about here in the let me represent like this. IB, solar beam radiation is falling on the solar module and it is making an angle theta with a normal. Okay, normal is a blue line. Okay, over here. So what happened is that, see, like any kind of a solar module or a solar collector that we use in a practical purpose, what we do is that we try to we always try to like make the solar radiation that is falling on that particular module. Okay, we always try to make it perpendicular all the time. you know that the sun, the motion, the movement of the sun. If you imagine the sun, the sun rises from the east and it set on the west. During this process, you will find that the sun occupies different position in the horizon, isn't it? So that means the IVN that I'm talking about, okay, the IVN and also the theta that I talk about is going to be, like it's going to be changed throughout the day. All right, but as a electrical engineering student, all we have to do is that we are more interested in that particular solar radiation where what happened. Okay, when the solar radiation, those like those portion of the solar radiation which is normal, we are always interested to those solar radiation which is normal to the surface. Okay, that's why I'm gonna consider. That's why I'm considering. Let's have a look at the slide again. Have a look here. Yeah, the normal to the plane surface, the equivalent flux following normal to the surface is given by I. That's why we are trying to find out the IVN cos theta is nothing but, have a look here, this component. Okay, if you imagine this is triangle, a small triangle between these, a small triangle, and this, if you consider this is IBN and this is a theta, obviously this side is going to be no, you have to imagine like this. Okay, the theta, you have to the triangle, inside the triangle you have to consider this angle is 90 degree. Okay, and this is the theta. Okay, so this portion, ये वाला portion जो है, this is nothing but IBN cos theta है ये. Okay, what is that? This is IBN cos theta. Let me repeat again. This is the IBN. This is the normal. This blue line is normal. Now the angle is actually the angle between these two lines. This is the blue line and the yellow line is something like theta. Now imagine a imaginary triangle inside it, and the component of the solar radiation in this direct over here, this small triangle, it is going to be what? IBN cos theta. Okay, there's nothing but the norm, the solar radiation which is normal to the solar module. Okay, that's why I have shown here. If theta is the angle between an incident beam radiation of IBN and normal to a plane surface, then the equivalent flux following normal to the surface is given by IBN cos theta. I hope it's clear. Now, the theta, the angle between an incident beam radiation and the normal to the plane surface, is related by many parameters. Okay, the first parameter is like declination and the sun and the earth position at the particular day of the year. All right, surface azimuth angle, you will come to know what this term is all about. Another thing is something called the hour angle, and the slope that I have already mentioned before. It is the tilt angle of the collector or the solar module. Okay, so all these things are actually related with the theta that I have talked about here. Okay, the theta, for example, let's say today is today is which day? September 9, 2020. So on this particular day, the value of the value of the latitude, the value of the declination angle, the value of the azimuth angle, the value of the hour angle, the value slope will remain same. Okay, these values will be different. So based on that, the cos theta, the theta value is going to be different for every single day in a year. Okay, so you need to, in order to estimate solar radiation received on a particular surface, you have to have the idea of all these parameters. Okay, so now let's try to figure out the all these parameters one by one, right? So initially, and this is nothing new, latitude of a location. Yeah, it is the angle made by the radial line joining the location of the center of the Earth with the projection of the line on the equatorial plane, right? By convention, the latitude is measured as positive for the northern hemisphere. It can vary from minus 90 degree to plus 90 degree. Let's have a look. You guys already know what is latitude all about, but let me give you a okay, this shall I save this one? Not necessary. Okay. Anyway, I'm gonna take a new don't save. Yeah. Imagine that this is the art, right? This is art. This is center of the art. Imagine this is the equatorial plane. Okay, equatorial plane. Imagine you are standing somewhere here on the art. You're here at this point. That's the A. You're standing at a spot. Now, imagine an imaginary line that connects the place where you are standing on the top of the art. I mean, on the surface of the art that is at point A, and you try to connect to the center of the art. It's nothing but a radial line that joins between center and the place of the location where on the surface of the art we have a line here from here to here, and the angle basically you can see like this line. This is on equatorial surface. Yeah, this is basically the equatorial plane. Okay, because this the lane is basically made by the equatorial points basically. Okay, that's why it's known as equatorial plane. And you know that over here, there will be some kind of an angle. Okay, if you are standing over here at this point, latitude का value कितना होगा? 0 हो जाएगा. ठीक है, isn't it? 0 degree. If you're somewhere here at this, alpha value somewhere close to 45 degrees because it is somewhere in the middle. And this is in the northern hemisphere, therefore it will be positive. In the North Pole, somewhere if you are somewhere here, then the phi क्या हो जाएगा 90 degree, isn't it? Okay, sorry, 90 degree. Like this, if you're somewhere here, यहाँ पे भी negative हो जाएगा phi का value. Okay, the latitude will be negative in the southern hemisphere. Value let it be somewhere like 35 or something like that. And obviously यहाँ पे South Pole में ये क्या हो जाएगा 90 degree. Yeah, minus 90 degree. Okay, plus 90 degree. Minus 90 degree. Okay. And writing is too bad. Okay. Please bear with it. Anyway, like this. Okay. So let's see the definition again. By joining the center of the art with the projection of the center of the art with the projection of the line on the equatorial plane. मतलब यही है. This one, this. Okay, and when it projected here, it will be मतलब यही this angle. This is phi. This is the phi. Okay. That's why it's saying that it can vary from minus 90 degree to 90 degree. Fine. This is quite clear. Next is we have declination angle. Okay, let's read this definition first of all. It is an angle made by line joining the center and the arc with projection on the equatorial plane. Let's have a look. Okay, now imagine this arc, the center of the arc. Imagine this is the equatorial plane. You have sun here, the center of the sun. Imagine a line that connects the center of the sun and the center of the arc. Now this angle between this line and the this angle is nothing but the declination angle. Okay, so let's see the definition again. Is the angle made by the line joining the centers of the sun and the earth with its projection on the equatorial plane. Projection मतलब यही है, ये वाला part. Okay. So this theta, this declination angle, it changes throughout the year. Okay, its value is maximum in the positive at June, probably 22nd or 21st. Let me have a look here. 21st June. Okay, and its value is maximum in the negative direction in December 21. Okay, at a particular, have a look here. Let's see this figure. Okay, sure. Yeah, this value, okay, the declination angle is actually positive maximum. Imagine that this particular, let me, this particular line is nothing but the axis, the pole axis. Okay, this is the pole axis. This is the equatorial plane, right? And this is the angle, positive angle. But declination is positive. In joint 21, now the value will be when it goes further towards September, ये positive कम होते जाएगा. Then at September 22, that is the day is known as equinox. And that particular day, you will find that the pole will be coincide. Have a look here. ये दोनों coincide हो जाएगा अभी देखो. This is basically we will the art is basically revolving like this. Okay, it is the on part. This part, imagine this. Imagine, you can imagine this as a plane, some kind of a plane. Okay, so that plane is nothing but this one. Okay, so therefore this value will keep on decreasing when it from joint 21 onwards. It process, let's say 31, it will be decreases again August 4-5, let's say, then you will keep on September 22. At September 22, the delta will become 0, the declination angle will become 0. This condition you will find. Okay, sure. As the arc crosses September 2022, let's say when it becomes September 23, now the declination angle will be started having negative value. Okay, so like this, the negative value will keep on increasing until December 21. At that particular day, you'll find that declination angle is maximum minus 23.55 degree हो जाएगा. After crossing December 21, that value, negative value, will be keep on decreasing, and after that, after reaches March 20, now the same situation like this, the delta will become 0 degree again. After that, it will started having positive value till and keep on increasing, and the cycle keeps on, happening again and again. Okay. Anyway, now Now let's have a look how this declination angle arises. It is due to the fact that the Earth's polar axis and its revolution plane is nothing but what is due to the inclination of Earth's pole axis and its revolution plane around the sun. That the revolution plane around the sun मतलब यही है, ये वाला लाइन जो ये वाला लाइन, ठीक है ना? यहाँ पे ये वाला लाइन, यहाँ पे ये वाला लाइन, मतलब सेम है ना? देखो isn't it? Only this is the polar axis was like this. अब ये कौन साइड हो गया, फिर इस तरफ चला गया, isn't it? So let's have a look again. The declination varies from minus 20 to 30.45 degrees to plus 2345 degrees, right? So this value can be exactly found out. See, for example, let's say if you want to find out the declination angle on, let's say January, imagine February 2, okay, February 2nd, you can use this formula. Have a look here. The declination angle is given by this equation. You can use this formula. That is 23.45 sine 360 divided 365 to 84 plus n. N is nothing but the day of the year, or you can say any day of the year. For example, let's say if you want to find out the declination angle on February 2nd, the n value will be, for January it's already 31. For the February again, if you consider up to 2nd February, then it will be, and you will add another two days. Matlab 31 plus 2, that is actually 33. So on February 2nd, the n value will be 33. Okay, so you just have to put the value of n equal to 33, and you just solve this equation. You'll get a declination angle. Okay, so based on the value of the n, you will find that sometimes it will be positive, as I've already mentioned in some video. So that's what I have shown here through this figure. Fine. Now another term called the surface azimuth angle. It is an angle made. It is an angle made in the between the line due south and the projection of the normal to the surface on horizontal plane. Okay, let's have a look for the surface azimuth angle all about. Anyway, see, for example, let's say this is you, okay, that's you. Use a compass. Compass basically gives you the direction, isn't it? So using a compass, at any point on the surface of the earth, you will be able to find out which direction is north, which direction is south. Exactly at that point, you can figure out using a compass. So, anywhere on the surface of the earth, the south, we call it the due south, okay? The due south of that particular point can be found by using a compass. Okay, now, I'm going to consider a figure in order to explain the surface azimuth angle. Let's see where okay, here is that. Now imagine that figure. Now imagine this is the horizontal surface or horizontal plane for the time being. Okay, this one, this boundary. This is horizontal plane. Okay. Now there is a tilted plane, or let's say you can imagine this is some kind of solar model. Okay, now it's tilted at a certain angle called beta, like this. This angle is beta. Now, our imaginary perpendicular line or a normal to this plane is shown by this line. This is written here normal. Okay. and this line is the vertical line which is actually perpendicular to horizontal plane. ठीक है ना? Now imagine that this is the IVN that I already talked about. Okay, ठीक है ना? The IVN that I already talked about, and have a look here. The theta, the incident beam, is nothing but the angle between this incident beam and the normal. It is the normal, है ना? With respect to this tilted plane, and this is the theta. Okay. Now let's try to understand what is azimuth angle, surface azimuth angle all about. Now, this normal to the tilted plane, when you project this line to the horizontal surface, here's the horizontal surface, है ना? You project this tilted plane to the horizontal surface, ये line जो है ये हो जाएगा. When you project this line to the horizontal surface, you'll get this line, this dotted line. Okay. I've already talked about the view south for this particular point. Through using I can figure out this direction is exactly pointing the southern direction of the arc. Okay, so this is the due south. This line, this is a dotted line here, and due south. It's also in the horizontal line sometimes known as due south. In some book, you'll say due south. Okay, so the angle between this due south and the projection of this normal to the horizontal surface is nothing but this one. So this angle between this line and between this line is nothing but this angle. This is nothing but the surface azimuth angle. Please remember. What is that? This is the surface azimuth angle and denoted by this Greek letter. Okay, let me repeat again. You have a tilted plane. This is basically tilted on this horizontal plane with a certain angle called beta. And this tilted plane, the normal of this tilted plane is nothing but this one. All right. Please remember one thing. This normal to the tilted plane will coincide. This line will coincide with this vertical line when beta is equal to 0. As already explained before. Okay. This line will be coincide with the vertical line if there is no slope. Okay, fine. Now, this for a time, imagine there is tilted at a certain angle beta. Now, with respect to that, there is a normal here. If this normal line on the surface, this is the line, and this is the due south. And if the angle between these two lines is nothing but the azimuth angle. Please remember. Okay, we call it azimuth angle. Let's read again. Yep. It is the angle made in the horizontal plane. I already told you the horizontal plane between the line due south and the projection of the normal to the surface on the horizontal plane. It can vary from minus 180 degree to plus 180 degree. Please have a look. Plus 180 degree to F. Have a look here. This is the line due south. This will be, if you imagine this is the eastern side and this is the eastern side with respect to the southern line. The yellow side is imagine this is east. Imagine this side is the west. Then, your condition is if you consider this is west, then the azimuth angle you have western direction with respect to this due south. If the angle is in this direction, okay, ऐसा होने से क्या हो जाएगा? The azimuth angle is in the eastern direction. Okay, so if the azimuth angle is in the eastern direction, it will be considered positive. Okay, मतलब ये जो है in the western side it will be considered minus. In the now have a look here. This can be from here ओके यहाँ तक मतलब ये कितना है another 90 degree this side मतलब 180 डिग्री मतलब ये क्या हो जाएगा ओके यहाँ से यहाँ तक यहाँ से यहाँ तक so like this what is that? That's all about the surface azimuth angle. I have written here the angle is positive if the normal is east of the south and negative if west of the south. Okay, I hope this is clear. Our angle. Another term called hour angle. All right. So let's read the definition first of all. The hour angle is an angular measure of time to 15 degrees per hour. It's from minus 1 degree to plus 1 degree. Okay. Now let me show that like this. Okay. ठीक है. सबसे पहले noon. Noon. Imagine this is noon. Okay. Noon 12 बजे. 12. This side में imagine this is 11 a.m. This is 10 a.m. This is 9 a.m. Okay, like this I can keep on writing all the a.m.s. On the other hand, 1 p.m. 1 hour difference, isn't it? 2 p.m. another 1 hour difference, another 1 hour difference, 3 p.m. Like this, I can write dot, 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 dot. Okay, in this direction also. Now, for the hour angle, in order to define hour angle, noon to 11 a.m. is basically 1 hour. This is basically 1 hour, isn't it? This is basically 1 hour. 1 hour is equal to how much? As per that rule, 15 degrees. There you go, 1 p.m. This is also another 1 hour. Omega value क्या होगा यहाँ पे? 15 degree. Someone have turn on the mic, please. Please make it mute. Please make it mute. Now, from yeah, once one from once the have a look at from 12 to 1 p.m. you'll find that there is a difference of 1 hour, and that 1 hour it can be converted as 15 degree. But what will be the value? What will be the sign? It will be negative. In the case of AM, it will be positive. Yeah, positive हो जाएगा. Another thing again, if you consider 10 AM, यहाँ से 12 noon से लेके 10 AM तक, मतलब 2 hours हो गया. 2 hours. Isn't it? From 12 noon to 10 AM मतलब so इसका hour angle क्या होगा? 30 डिग्री हो जाएगा. 15 डिग्री प्लस 15 डिग्री, isn't it? मतलब 30 डिग्री. और इसका जो response, yeah, and it will be positive. On the other hand, for 2 p.m. यहाँ से यहाँ तक omega, there is nothing with the hour angle, मगर इसका साइन जो है नेगेटिव होगा क्योंकि ये PM है. ठीक है ना? Like this for 9 AM it will be कितना हो जाएगा? 30 डिग्री प्लस 15 डिग्री, मतलब यहाँ 3 hours हो गया है. Then it will be 45 degree. 3 p.m. इस तरफ क्या हो जाएगा? Minus 45 degree. Like this you can find out. ठीक है? Now the value that I talk about here, ये जो 12, 11, 10 AM, whatever the hour that I'm talking about, you have to consider while considering this particular, while finding out the hour angle, you have to consider a term called local apparent time. What is that? Local in the short form is written as is known as LAT. मतलब local local apparent time. Okay, so I'll tell you how local apparent time will be found out probably in the next for the time, whatever the thing that I talk about, have a look here. The academic definition of everything known based on local apparent, right? You have to consider a local apparent time for finding out the hour angle, being positive in the morning and negative in the afternoon. ठीक है ना? Okay. So yeah, another term that is slope. Slope, I have already explained what is slope all about. If this is a said hatch area, if you consider this as tilted plane, the angle the made between this horizontal plane and this tilted plane, मतलब ये जो angle जो है that is nothing but a slope. It can derive from 0 to 180 degree, obviously. So whatever the parameter that I talk about here, I already told you it is related with the theta. The theta, the angle of incidence at a day or time, it is all related with all the parameters I have talked about. And there is a relation. It's some kind of empirical relation where in order to find this particular equation, you have to do a lot of experiments. Based on the experiments, these equations is actually developed. Okay, this equation it's a very long equation, okay, isn't it? So this equation is actually developed by vigorous, practical, by analyzing a lot of practical data, and this particular equation comes up basically. Now, still, this equation can be proved. You can prove that this equation is wrong. Okay, so it is accepted by the researchers or academicians all over around the world. For the time being, this equation is used to find out the theta. That is the angle of incidence of the beam radiation, and this is the equation. Okay, so this is a long equation you have to remember. And now all this equation through this general equation, let me just represent with the equation number like this so that it will be easier for me to the equation number. So through this general equation, we will try to develop a lot of equations and relations. Okay. So for the time being, for today, let's wind up here. Everybody, can you hear me?
Yes, sir.
Yeah. Some of you asked about the what kind of a book it will be used. Let me tell you the name of the book. Let me share share it on the the name of the book on the WhatsApp. Is it okay? So with this, let me conclude for today's lecture. Okay, have a good day.
Sure.